Hi, everyone, and welcome to another great session of Green Nickel 101, your source for eco-friendly EV nickel discussions. My name is Leah. I'll be your co-host today.
And I'm John.
Hey, John, it's been an incredible week.
It has, in fact. Yes, it has.
I
think it was exciting to get our season 3 going last week, getting all these creative juices going, the thought process, discussing some of our new episodes that are up and coming. So I think it's going to be an exciting season 3 and certainly looking forward to it.
Yeah, and our beloved Captain Kirk had a chance to fly up in low orbit. It put a new meaning to the beam me up, Scotty. It was more like beam me up, Jeff.
It was spectacular. Yeah, I think that was something that touched the whole planet. And, if you look at Star Trek, which started in the 60s and developed such a huge cult following, especially through the 80s and then with the introduction of the movies and stuff. I mean, you have this figure, 90 years old, William Shatner,
right?
Good old Canadian boy, went to McGill University, performed at Stratford.
I think every Canadian was pretty, happy for him.
Yeah, but for him to be able to touch and join an elite group of people that have been to space.
Yeah, and you know what? Who knows? Maybe one day we'll have battery-powered rockets.
Possible, yeah.
I think that would be a far-fetched, but we'll save that for another day. You know what? Today's episode, we're going to focus on battery versus hydrogen power. But listen, before we get started, let's quickly recap our previous episode. We talked about sustainable certified batteries. Eco-sustainable, safe batteries have some kind of an accolade or certification program so that consumers can know what they're buying when they're buying their next electric car, right?
Consumers demand transparency these days. Mm-hmm. And there's so many levels that go into the production and manufacturing of anything. So to be able to gain that transparency on the journey that products take from start to finish, I think is very important for consumers these days.
Yeah.
Which obviously applies to battery storage and EV technology.
Yeah, and transportation. So certifying batteries that use sustainable, safe, eco-friendly materials, the processes that are, involved, and the supply chain and labor and all that sort of thing, making sure that the materials are properly sourced and doing it in a safe way. So we also talked about building Canada's sustainable battery supply chain. So that was a great episode. And if you missed it, you got a chance to check it out.
Yeah, I think what was interesting about the Spotlight is just impressing upon Canadians to be leaders. They can be leaders in this sector of the battery supply chain as opposed to being a passenger.
Right. So. Yeah, and here's our chance. But now let's move on to this week's discussion, battery versus hydrogen power. All right, so, all of our episodes up to this point are a great recap. Like, if you take little bits and pieces of all our last 3 seasons, we can come up with a recap on the benefits using Ni nickel battery technology. There are other types of batteries out there. Let's focus on the nickel.
So we have a firm understanding at this point of what is encompassing battery technology.
Yeah, so let's look at the
battery
pros.
Storage. So what we're trying to do in this episode is throw kind of a fly in the ointment. Let's get a punch or a counterpunch going here. We've established that it certainly appears that the world has embraced the battery platform as it pertains to mobility, energy storage, domestic storage as well. So, a lot of people talk about hydrogen power and how is the hydrogen platform, how does it look moving forward? Will it challenge the battery technology? Can they coexist? This is
well. Let's break it down. Let's look at the nickel battery technology, right? Give me some benefits. So, top of the list here, we got good energy density versus, good range versus cost, right? We know we can get pretty good combination, low kilowatt hour cost and very good energy density using a nickel X battery configuration. That's a benefit, right?
Yeah.
Good bang for your buck. And it can be sourced environmentally friendly and sustainable using nickel sulfide deposits, so that when sourced from socially, environmentally, and governmental responsible regions like Canada, we minimize carbon and toxic footprint. So it can be done. Of course, there are messier ways to do this, but it can be done. It's proven. We've talked about it in our previous episodes, right? Mining nickel sulfide in a responsible way is in line with global green initiatives and supports an efficient transition to a global electrification of power storage and transportation. There's another benefit, right?
Yeah.
Just going down this list, I have a whole bunch of talking points here. You want to chime in on any of these?
I think what I'd like to say, and if anyone who's actually listened to all our episodes, which I hope all of you have,
If you haven't,
start
don't
on
do that.
episode one.
Yeah.
Start on episode one. Take the journey with all of us. So, what the battery storage platform does is it checks all or most of the boxes moving forward from an efficiency point of view, cost effectiveness,
Safety,
environmentally
we
friendly.
talked about that.
Yeah. So what I think we want to explore here is, how many of the boxes does the hydrogen platform check?
Well, I'll go through a few because you know what, somebody's got to take the hydrogen side, so I'll volunteer. But before we do that, let's add a couple more to the list of batteries, right? Versatility of battery technology. It's pretty good. It can be used in household applications, stationary storage. It's very flexible. Transportation, not just consumer transportation, but also commercial. And anything that I missed? Maybe rockets one day. Maybe Captain Kirk will be on a rocket-propelled, electrified, something or another.
One of the phrases that Elon Musk has tended to use quite a bit over the past couple of years is scalability.
Right.
You can have a great concept. There's so many, you imagine how many different avenues are being pursued in this renewable future that we're moving towards. And there's so many forms of technology that potentially could challenge battery technology, could challenge hydrogen, etc. But are they scalable? Can you actually take this great idea and scale it into a format where
globally?
Where you can produce 100,000 units a day out of a factory. So the beauty of the battery technology that is being developed today is it is in fact scalable.
Right.
The NCM combination.
I think Tesla's proven that.
Yeah.
They're slowly. I mean, one of the things they got hammered on was the fact that maybe they produced maybe 50,000, 100,000 units a year, and General Motors, larger companies were doing millions. But fast forward 2 years, 3 years, and now they're doing 500,000 plus. I think they're past those numbers. I think I'm behind on those metrics. I think they're quickly approaching the $1 million or a million piece or units a year of production.
Exponential growth.
Exponential growth. So they're showing the scalability model, and they picked the battery. Of course, they could have went with hydrogen fuel cells or combustion programs, but they said no. We think this is where the future is, and that's what their decision was. And let's see what happens. Safety-wise, though, it's proven battery technology has proven to be relatively safe, and it's getting safer. We talked about instead of liquid electrolytes, we talked about using solid state. That would definitely, make things a little bit safer on the battery side.
A higher energy, and the platform is moving towards solid state within the next, call it 3 years.
Right. So we can check that off the list, I would think. So,
greater energy density, more safety, greater range, lower cost.
Right. So. Lower cost. Yeah. And they're going down. They continue to drive them down. So let's talk about pros for hydrogen, right? I'll start first here. So the byproduct, one of the things I loved about hydrogen, early on, this is way before Tesla even came out and said, hey, we're going to build cars. Maybe about 8-10 years ago, I heard about a combustible engine that used hydrogen, and the byproduct was water vapor. I was elated. I was amazing to hear this. I'm like, wow, this is amazing. This will fix all our carbon emission issues. Clean exhaust if combusted. Great plus. I think I watched a video once, and somebody put like a glass underneath the muffler, and you saw water droplets just, going in there. I don't remember if the guy drank it or not, but it gave you the perception that he could, Also, hydrogen is a very common element. It's all around us, H2O, like in water, there's hydrogen.
I'm going to be the devil's advocate here. How are we producing and collecting the hydrogen for ultimately being used in?
Well, it's got to get extracted. Yeah. And we'll get into some of the cons there. But let me give them a few more pros here. Let's give them a few more check
Before
marks.
we slam hydrogen, let's work on the pros first.
We're not trying. Listen, if hydrogen was the silver lining, I'd be all team hydrogen. Right now, I am team hydrogen. So let me continue here. So it doesn't need to be mined per se. So we're not having to get all kinds of heavy equipment, and it's not prone to those mining challenges of, extracting ores out of the ground using whatever questionable, labor challenges or equipment
things
challenges.
we discussed in our previous episode,
Yeah, exactly. So it has to be extracted, okay? But let's say one of the good things, it doesn't have to be mined. Another thing is hydrogen could be both used in a combustive kind of technology, like you have a combustive engine that actually burns liquid hydrogen, or maybe a combination of that and oxygen. But you also have hydrogen fuel cell technology, which is a pretty efficient way of getting electricity created through this process, hydrogen fuel cell technology, right? Yeah. We won't go into the details of that.
But it ultimately produces electricity to power an electric engine.
Yeah, it's very efficient. It's not as efficient as fusion, let's say. That's very efficient, but it's a very good, efficient way to get electricity through that process. So those are great pros for hydrogen. Now let's go into some of the challenges here. You were mentioning a couple just earlier.
Yeah, well, scalability was one of them.
Yeah, well, on the extraction side, right? So you wanted to say, hey, look, on the how do we get the hydrogen? All right, let's go into that. And we have a great couple of articles here we can reference. There are some definite challenges, and most of the hydrogen today is extracted or produced using not so green technology. There's an article here, Is Hydrogen Really Green? And I call it, the dirty truth. I didn't realize this, but reading this article is from ebrd.com. Again, we're going to have links to all these articles. There's about 3 or 4 articles we're going to reference. They're in our comments section. But in here, they actually give a name to the hydrogen that's produced by which method. So is there green hydrogen? There can be, but right now most of the hydrogen is either gray, which is sourced from natural gas, or black. Black hydrogen is referencing hydrogen that uses coal technology or coal power to use energy derived from that to get hydrogen, which is not very good.
It's not good, but I would say, case in point with even the EV and battery technology, I've been saying this time and time again through our podcast episodes, is that technology is forward-looking. And, the product or the technology that you have today may be the first step or the second step in a journey, okay? Funny little story. I'm not gonna do the way back time machine here, but I'm gonna provide an interesting analogy. One of the old University of Western Ontario Business School case studies embraced the idea of these chicken farmers, okay? And these chicken farmers realized, they came up with this technology that chickens actually produce more eggs under a red light environment. So you have 2 chicken farmers. The first one says, well, I'm going to talk to my buddy who's a sunglass producer and have him make 100,000 small little red lens sunglasses.
Chicken sunglasses?
Chicken sunglasses. You put the glasses on the chicken and they see red light and they lay more eggs. The other chicken farmer did something a little bit more simple. He just went through his whole warehouse, whole factory, and he changed all the white light bulbs to red light bulbs. Right. Had the same
Created
effect.
A red light district in the chicken coop.
Yeah, and they were popping out eggs like Tic Tacs. So, what I'm saying is you go through these different processes in trying to strive for greater efficiency, right?
Right.
So you make mistakes along the way. And I personally think that, although I see the hydrogen platform being somewhat cumbersome and flawed, you still have to go and fill up somewhere. You have to have tanks.
You have to transport the liquid hydrogen in a way.
But there's going to be space for the hydrogen technology. And I think, personally, they can coexist. You're going to have a long, many years of the ICE vehicles in decline. ICE vehicles will still be around for a long time.
And green
There's still gonna be
technologies,
petrol.
which can be a combination of battery, hydrogen, fuel cells,
There's gonna be
combustive.
enough room.
And we got a couple of references on how combustive hydrogen is still going to be around, I think, for a while, especially in aviation. I'll talk about that in a sec. But the pace of discussion on green hydrogen, if we can color code, the bad and the good, right, has picked up, especially since the outbreak of coronavirus, right? Because everyone's sort of, hey, now's our time for change, and now's our time to transition. Governments that include like Germany, Britain, Australia, Japan are working on or have announced hydrogen strategies. So, for instance, Australia set aside like 300 million Australian dollars, about 191 million US dollars to jumpstart hydrogen projects. Portugal is planning a new solar-powered hydrogen plant. That'd be good. Which produced hydrogen by electrolysis by 2023, only a couple of years from now. The Netherlands has unveiled a hydrogen strategy in late March, outlining plans for 500 megawatts of green electrolyzer capacity by 2025. So, yeah, just to give some accolades to hydrogen, we are transitioning, and we could very well see these gray and black hydrogen categories turning more green as time goes.
Turning more green, and you could have green hydrogen technology coexist with green battery technology.
Right.
But there again, I just see the concept being a little bit more cumbersome, a little bit less versatile, anyway, I mean,
well, you got German auto giants, you got BMW and Audi. They're starting to place bets on hydrogen cars. I don't think they're going to make all their cars hydrogen, but you know what? They're jumping on that coexistence bandwagon, right? They're developing hydrogen fuel cell passenger vehicle prototypes along with the fleet of battery cars. What do you think of that, John? I think that's a pretty good. I think it's a smart move. It's let the consumers decide. Let technology.
It's called hedging your bets. Okay,
they are hedging their bets. It's exactly what they're doing. They're calculating. A change in political winds could shift the balance towards hydrogen, right? In an industry that's shaped by early mover Tesla decision makers on going battery.
Well, there's an early mover advantage, right? And you either jump on the bandwagon with where it appears the industry is going, and in this case, obviously the industry is going towards more battery-based technologies for providing energy storage and mobility, or you can take a different approach and, as I just said, hedge your bets and explore the hydrogen platform. And I think that some of these automakers have chosen that path.
Yeah, these guys are hedging bets, all right, but they're billion-dollar bets. There's
economies of scale at play too. I mean, sometimes when you focus on one technology as opposed to splitting into two or three, you create some economies of scale for yourself. Case in point, Tesla's market mover advantage.
Yeah, and I think the decision to go hydrogen or battery electrification really depends on a lot of factors. But also there might be some niche sectors that make sense, like, in the steel, chemical industries, they may very well, in their challenge to meet climate targets, may very well adopt some of this hydrogen fuel cell technology out there.
Well,
it might make sense, right?
Airbus platform, I think, is an obvious choice.
Yeah, aviation. So Airbus has a new initiative. It's their zero emission initiative, where they're banking on hydrogen propulsion, not using fuel cell, but more propulsion or combustion technology to deliver a zero emission commercial aircraft by 2035. This article's on the airbus.com link. You can check it out yourself. And they call it the Zero E concept aircraft, right? And they're hoping that this will shape the development of future zero-emission aircraft. This aircraft is going to run on liquid hydrogen mixed with oxygen to power their jet engines. It's interesting. And what comes out the back, and right now, like, these aircraft are using kerosene, obviously aviation fuel, which is kerosene, which is a pretty efficient of the fossil fuels. And but they burn so much of it that I mean, this is a much better way, much cleaner, greener. Like,
Well,
I mean,
it's an exciting
the trailings will be
platform.
all vapor, basically. They're creating clouds in the skies, basically, right?
I will throw one question out for you here, being our hydrogen representative today, Leo.
Team Hydrogen, go H.
How combustible is hydrogen? What are your risks of an explosive scenario?
Well, that's the challenge, right? So look, high pressured gases like propane have been around a long time for cars. Why didn't they take off? I don't want a 3,000 pounds per square inch tank behind my seat or below my seat. I just don't feel comfortable with that. They've done a lot of tests on gasoline tanks, and it's very hard to blow one up. Like, it's really the vapors.
It's not under pressure.
It's not under pressure. You might have a gas leak. There could be a trail. And, unless you're, I mean, in cartoons, they kind of make it a little bit animated where, the coyote and the Roadrunner episodes there, where
But
you
the
got.
beauty with the coyote is he always survives.
He always survives.
Unfortunately.
Yeah. But you don't want to be the coyote, right? You think to yourself, hey, I don't want to be that coyote sitting behind this strap to this
the rocket
tank,
going up in the sky.
Right. High pressure tank. So I don't know. People, I think, are a little concerned at that. Now, if I were to put a big high pressure tank in the wings of an aircraft and it's commercially, engineered and all that kind of stuff, I feel a lot more safer about it. I mean, you are, let's say, 30,000 feet in the air anyway.
Well, there'd be a bit of a stigma they'd have to overcome there, because I'm sure that, I just mentioned it, just popped into my head. Well, what about the combustion?
It's a very good point. And that's one of the reasons why hydrogen vehicles, didn't really take off. It's the safety of it. It's the perception, even if it's a false sense of, safety. I feel safer being in a gasoline powered car than a propane powered car that has a tank somewhere near the engine and stuff. If you ever watch YouTube videos of some of these propane tanks going on fire, it is like you have these barbecue tanks that go up. They're super hot, very destructive. You can't put them out.
So you're suggesting then that a hydrogen tank could explode or combust in a similar fashion to
safety has always got to be the number one top high priority when you're using these technologies. And although you've had like batteries that combust and can go on fire and all that, and we've talked about how technologies are coming out with solid state and everything else, and also
to eliminate those problems,
and the circuit boards and the programming on them too. They got to be kept cool, and they got to be kept in stable kind of formats and stuff. And solid state does that quite well. And listen, I'm not a scientist.
Well, I think the moral of the story before we move on to our spotlight here is, again, touching on all these technologies, don't be putting rose-colored glasses on your chickens. Change the light bulbs. Right. Makes more sense.
Makes more sense.
So you apply that concept to any of these formats. I'm sure that whatever hurdles there are to overcome can be achieved through a bit of engineering, a bit of common sense, and obviously...
and I think they will coexist in different applications in different industries. And, it makes sense to use batteries for consumer transportation and probably to some extent storage, stationary storage applications. And it's going to make sense to use... hydrogen fuel cell and combustive propulsion systems in certain technologies. So, listen, you know what? The answer is up to our consumers. We're going to decide, and time will tell. And we'll leave it up to our listeners to opine, and we'd love to hear your comments. And with that said, you know what? It's time for our spotlight. This week's Spotlight has been brought to you by Tardison Nickel.
Tardison is drilling its Kenbridge nickel sulfide project in Ontario to expand the resource and meet the needs of the rapidly growing EV battery market. Class 1 nickel is an essential component in battery production and a critical element in the North American supply chain. The Kenbridge nickel deposit indicates there is significant potential to expand the mineral resource estimate with additional high-grade targets at the Kenbridge North site.
Tardison Nickel, TN on the CSE.
Yeah, we have an exciting spotlight this week, Leo, because we touched on building Canada's battery supply chain.
Right.
And how, we firmly believe that Canada can be a leader in all of these...
Instead of a passenger.
Important minerals in the battery supply chain. And it's going to take the cooperation of governments and the initiative of some of these mining companies and junior exploration companies and investors
to step up,
participate in a private placement, put your money into something that you've done your due diligence on. And, we've explored some of these companies in previous episodes, and it just so happens we're going to.
Well, one of our sponsor, Tartisan Nickel, they announced a 10,000-foot drill program back in several months ago, and they've been working diligently on the. And guess what? You know what? They just announced some PR this week.
Yeah,
that's why it's in existence.
They announced 2 drill holes a week ago. And they announced 2 drill holes this week. Assay labs are quite slow, so it's not like you're releasing 10,000 meters of drilling all at once. You're releasing 1 or 2 or 3,000 meters at a time, right? So.
Yeah, and for our listeners, if you want to read more about it, go to tartisannickel.com. In the news section, right at the top of the list, or near the top, depending on when you're listening to this podcast, you'll see Tartisan Nickel intersects 25.5 meters of 1.13% nickel, 0.61% copper, including 4.5 meters of almost 3% nickel. These numbers are incredible, and 1.5 meters of 4.17% nickel. Am I reading this right? This is incredible.
Being a nickelhead, okay, we're nickelheads, and hopefully most of our audience are nickelheads as well. If they weren't before, they should be now. And, if you're reading press releases from some of these junior mining companies out there, you're seeing results of, 0.3% nickel over 50 meters or 0.5%. Once you're getting over 1%, those are big results. I defy our audience to go out there and try and find some nickel results that are
north of 2%, 1.5%.
Even mentioning 4%, even though it's over a small target, 1.5 meters, very significant. It certainly implies that there's more there.
You know what? Just to give some perspective to our audience, this is the Kenbridge Nickel Copper Cobalt Project in northwest Ontario,
near Kenora, Sioux Narrows,
and this feeds right into this whole concept of Canada, being a big supply chain,
being a leader.
Right? And junior mining operations like Tartisan's, that stepping up to the plate.
Well, again, if this headline doesn't garner some attention, if this headline doesn't get in certain market leaders out there and investors excited, I don't know what does. I mean, these are fabulous results.
There's a lot to digest in these numbers, and I'm not a geologist, ladies and gents, but you know what? We're going to have a geologist come on board in one of these future episodes that'll help break down some of these numbers for us, because I got a whole bunch of questions myself, and and understanding what these actually mean. All I know is they're good numbers from what I've previously seen.
A geologist would be a logical step forward and help filling some of the gaps. And as we're going on this journey together of expanding our perspective and our knowledge base on this crazy sector of the ever evolving, exciting sector, to bring a geologist in to add a little bit more advanced perspective, I think.
Taking another layer off the onion, itself,
yeah.
Right? Well, listen, with that being said, John, we've reached the end of the show. So thank you for joining us. We hope to see you next week. Don't miss it. Let us know what's on your mind. You can find us on Twitter and Instagram. Our handle's @GreenNickel101. We'll answer any questions on our upcoming episodes, and be sure to leave comments and opinions. And remember, we upload new episodes every week. And until next time, think nickel
and have a green day,
fellow Nickelheads.
Thanks, everyone. Have a great week.
Take care. Tartisan Nickel, traded on the Canadian Stock Exchange, symbol TN, or over the counter, symbol TTSRF.